I was recently watching Guillermo del Toro's Frankenstein when I started wondering exactly how many calories are in a single lightning bolt, and if I could somehow blend it into a protein shake, how long could I survive on it? If you manage to trap a standard cloud-to-ground lightning bolt in a very sturdy thermos, the answer is surprisingly manageable. A typical lightning bolt releases about 1 billion joules of energy. In the units we use for food, the kilocalorie that works out to roughly 239,000 calories. From a nutritional standpoint, this is actually a bit disappointing. It's about 430 Big Macs. If you are an average adult eating 2,000 calories a day, a single bolt of lightning would keep you fueled for about 120 days. It's a decent meal prep strategy, but it's not going to solve world hunger. You'd need to get struck roughly 3 times a year to maintain your current weight, though the side effects of being struck by lightning 3 times a year would likely include not having a weight anymore. But the problem isn't the amount of energy. The problem is the delivery. A Big Mac releases its 550 calories over several hours of digestion. A lightning bolt releases its 239,000 calories in about 30 microseconds. If you tried to consume this energy, you'd be dealing with a power output of roughly 33 terawatts. For that brief window of time, you would be consuming more power than the rest of the human race combined. I'm not sure what your workout routine looks like, but that is a very aggressive bulk. To understand what happens next, we have to look at the temperature. A lightning bolt is roughly 30,000 Kelvin, which is 5 times hotter than the surface of the sun. If you tried to hold this meal in your mouth, you wouldn't just be burned. The water in your cells would undergo a phase transition into steam so rapidly that it would qualify as a high-order explosion. Let's say you ignore the biological constraints and try to store the bolt in a standard kitchen appliance, maybe a very high-end blender. As the bolt enters the blender, the air inside is instantly converted into plasma. Because plasma takes up much more space than air and it's being heated to solar temperatures in a millionth of a second, it creates a supersonic shockwave. In your kitchen, this is experienced as thunder, but at a distance of 3 inches, it is more like being inside a detonating claymore mine. The glass of the blender doesn't just shatter, it's pulverized into a fine, incandescent mist. The sudden expansion of air would blow the windows out of your house, strip the wallpaper off the walls, and likely launch your toaster through your neighbor's roof. If you were standing nearby with your protein shaker, you wouldn't feel the heat first. You would feel the displacement. The air pressure alone would be enough to collapse your lungs before the radiant heat turned your kitchen and your sourdough starter into a localized sun. Within a millisecond, the calories have been distributed, not into your digestive tract, but into the structural integrity of your suburbs. In the end, trying to live off lightning is a bit like trying to get your daily glass of water from a high-pressure fire hose aimed directly at your face. You'll get the water, but you won't have a face anymore. Nature is very good at creating energy, but she is notoriously bad at packaging it for home consumption. We should probably stick to the Big Macs. Leave the lightning to Victor Frankenstein. He wanted to conquer death, but even he knew better than to try and drink it for breakfast.